Hello, so let's now calculate the variance of a hypergeometric random variable. So as a recap, the PMF of a hypergeometric distribution is given by this, where our R goes from 0 to n and our n also goes from 0 to n. R goes from 0 to k, n goes from 0 to n, and uh, k also goes from 0 to n. Okay, so earlier we calculated the mean of a hypergeometric random variable, which came out to be nk over n. Okay, so this means that if by using the formula I have r and r n minus n k minus r divided by n choose k, this is equal to n k over n, and where r goes from 1 to k. Okay, now what our job is to find the variance. So variance of x, so this is equal to e of x squared minus e of x squared. So this guy is this guy, and we are interested in finding this guy. So now let's use the definition. So now let's start doing the second moment. So then this guy is equal to what? We have r squared, and choose r, n minus n, k minus r divided by n choose k. R again goes from 1 to k. Okay, actually it's still from 0 to k, but since r is getting multiplied, so I can say 1 to k. Now use r times n r. This is equal to n times n minus 1 r minus 1. So then I can write, so then this guy, so this is, I write use. So then this guy, now let's shift it a little bit up. So this guy is equal to, I can say n outside, and I can say r is equal to 1 to k, and then I can say r n minus 1 r minus 1 n minus n k minus r divided by n choose k. Now use change of variables as we did earlier. So the change in variable will look like what? So change in variable is m is equal to r minus 1. This means r is equal to m plus 1, and the limits for m should be 0 to k minus 1. Correct? So then this guy will look like what? We have n outside and n choose k in the denominator outside. So this guy is m is equal to 0 to k minus 1. Then I can say m plus 1 times n minus 1 m, and here I can say n minus n k minus 1 minus m. Okay, okay. So now let me split these two summations. So I will write it as n over n choose k and big bracket. My first summation will look like this. I will say m is equal to 0 to k minus 1 m times n minus 1 m, but this n minus n, let me write it as n minus 1 minus n minus 1, and here I can say k minus 1 minus m. Okay, and then the next summation will look like k m is equal to 0 to k minus 1. I can say just n minus 1 m, and here I can say again n minus 1 minus n minus 1 and k minus 1 minus n. Okay, so I should write brackets here just for the sake of clarity. Okay, now what is this guy? Now this is a hypergeometric distribution without the denominator, of course, but it's a mean of that, right? So it's a mean of a hyper. So this I can say this guy is mean of a hypergeometric random variable with parameters n minus 1, uh, n minus 1 and k minus 1. Correct? So then this guy should be what? By the definition, our mean is this guy, right? So I can just say this is equal to n minus 1 k minus 1 divided by n minus 1. But this is only true if I have in the denominator something, right? So I have to multiply by n minus 1 choose k minus 1, correct? Because this on its own is not true because it has some denominator like that. Okay, what is this guy? This guy is just the summation of, so sum of PMF of hypergeometric random variable. So this guy with parameters the same n minus 1, uh, n minus 1 and k minus 1. So this guy should be equal to just n minus 1 choose k minus 1. Okay, so then this means my second moment looks like this. I have n over n choose k. Then I can say n minus 1 choose k minus 1. Then I can say again a bracket n minus 1 k minus 1 over n minus 1 plus 1 plus 1, right? Okay, so plus 1 is this guy. So now if I simplify this divided by this, so let's see n minus 1 k minus 1 divided by nk is what? This guy is equal. This guy, if we use the definition of combinations, this guy we get k over n. Okay. Okay. So then so my second moment is n k over n minus 1 k minus 1 over n minus 1 plus 1. Okay. Now, okay. So the variance is given by this. So then I will write variance. This is equal to n k over n n minus 1 k minus 1 over n minus 1 plus 1 minus n squared k squared and n squared. Correct? I can do that, right? Okay. So then let me take n k over n common. So then this is equal to n k over n. Then I will say n minus 1 k minus 1 over n minus 1 plus 1 minus n k over n. Now it's a basic algebra story. So now what I'm going to do is I'm going to first of all multiply this. So then this guy, this is equal to nk minus n minus k plus 1. Correct? Okay. So then I have nk over n. So then I have in the denominator I have n times n minus 1. So I multiply everything by n here. So nk n minus n times n minus k times n plus n, then plus n times n minus 1 minus n times k times n minus 1. Correct? Okay, now what can I cancel? Okay, so then uh, this guy is what? So this guy is n squared minus n, and this guy is what? Minus n k n plus n k. Correct? Okay, so then n k n and minus n k n, then plus n and then minus n. Okay, so how many terms do I have? I have 4 terms left. So I have, this is equal to n k over n, and then let me bring this in the denominator here. So I'm left with n squared minus n times n minus k times n, and then plus n times k. So then this guy can be factorized. So this guy is uh, n times n minus n minus k times n minus n. So that then this means uh, my variance looks like this: n k over n squared n minus 1 times n minus k times n minus n. So this is my variance of a hypergeometric random variable, where I've done nothing special here. I just it was long, but it was just starting with the definition and simplifying each step one at a time. Okay, so this is it about the variance of a hypergeometric random variable. Hope it was clear for you to understand. Thanks for watching. Hope you like